Hello, welcome to lecture 19 of CSE 4635. In this lecture, we will be talking briefly about design patterns, and we will also be taking a brief look at some of the design patterns that are used side by side with JEE technologies. So let's begin. So let's try and understand what design patterns actually are. So according to a definition from Wikipedia, in software engineering, a software design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. So let's see what we can exactly take away from this definition. So we can say that patterns provide us reusable solutions to recurring problems. They provide us solutions to general problems that other software developers have faced during their lifetime while they were doing software development. Design patterns are specific to a particular scenario, and the solutions provided by these design patterns are basically observed through experience. So whenever we actually face any problem, we actually look for a specific design pattern that applies to that problem, and then we use that pattern to solve that problem. So design patterns are typically written in a structured format. However, they cannot be directly converted to code. They only provide us a structured format of how we can implement our code so that our problem can be solved. Patterns can exist at different levels of abstraction. So for example, they can exist at presentation tier, at the business logic tier, at the data tier, and so on. Patterns help us prevent reinventing the wheel. And what that means is we don't have to constantly come up with solutions for the same problem over and over again. If we found a solution that works for a specific problem, we can use that solution in the future as well whenever we face the same problem again. So patterns, patterns essentially communicate designs and best practices. So they basically say that this is the best practice whenever you are dealing with this kind of problem. So finally, patterns can be used together to solve a larger problem. Now, depending on the different kinds of problems that programmers face in software development, there are different categories of design patterns. So the creational patterns are concerned with the way objects are created while hiding the creation logic rather than instantiating objects directly using new operator. So the creational patterns are concerned with the ways we can actually create objects while hiding the complexity of how those objects are going to be created. This gives the programmers much more flexibility in deciding which objects they need to create for which specific use case. So some examples of creational patterns are Singleton Pattern, Factory Method Pattern, and so on. Next, we have the structural patterns. Now, the structural patterns are concerned with the ways different classes and different objects are composed. Now, they use, or the structural patterns use the concept of inheritance to provide multiple ways different classes or different objects can be composed, so that depending on the kind of need, we can implement the same class or the same object in multiple ways. So some of the examples of structural patterns are adapter pattern, bridge pattern, facade pattern, and so on. Finally, we have the behavioral patterns, and behavioral patterns basically are concerned with the ways different objects communicate with each other. So some of the examples of the behavioral patterns are mediator pattern, observer pattern, state pattern, and so on. Now let's talk about the different design patterns that are used with JEE technologies. So JEE design patterns are basically any design patterns that are used to solve software problems that utilize JEE technologies. Okay, so now we already know that JEE technologies are classified into different tiers based on which technology we are using, right? So depending on that classification, JEE design patterns are also classified into 3 categories. So these are classified as presentation tier, business tier, and integration tier. So let's take a look at which design patterns are used at each of these tiers. So you can see that under presentation tier, we have different patterns like intercepting filter, front controller, view helper, and so on. Similarly, under business tier, we have business delegate, value object, session facade, and so on. And finally, under integration tier, we have different patterns like data access object, service activator, and so on. Now here you can see that I have highlighted 3 patterns which I feel like are going to be very important for you guys to understand, because if we can understand these 3 patterns, then we will be able to understand the other used design patterns as well. So in this lecture, we will be discussing the front controller pattern and the data access object pattern. Now, I wanted to discuss about the session facet pattern as well in this lecture. However, to understand that pattern, we need a little bit of knowledge about session beans, which actually falls under the EJB lecture that we will be having later on. So we will try to understand the session facet pattern after we have finished our lecture on EJBs, or enterprise Java beans. Okay. Now, before actually talking about those patterns, let's talk a little bit about the MVC pattern when it comes to the JEE technologies. So what we need to understand is it is possible to use or to implement the MVC model in case of the JEE technologies as well. So we have already discussed in great detail how MVC works in some of our previous lectures. So just to recap, the reason we use the MVC architecture is so that we can separate the presentation tier, the control tier, as well as the model tier. So this allows us to have a proper separation of concerns when it comes to our application. So such separation allows multiple views to share the same enterprise data model, which makes supporting multiple clients easier to implement, test, and maintain. Now, what are the main motivations when it comes to using the MVC model? So MVC model helps us to not mix the user interface code and the business logic. So the user interface code is or falls under the view layer, and the business logic falls under the model layer. Next, the advantage that MVC provides us is that it allows us to decouple the view and model so that development and maintenance can be done independently. So very easy to understand why this is important, right? Next, it allows us to have multiple concurrent views when it comes to our application. So our application can have multiple views, and all these views may depend on a single data source, right? So having a MVC model here allows us to separately develop for the view part and our data part. Now, the model should not depend on the view since it is not needed and since the view changes more often. Now, I will not talk in much more detail about the rest of the stuff of the MVC model, like the model layer or the view layer or the controller layer, because we have already discussed about those things in great detail in our previous lectures. So what I'll do is I will, when I will provide the slides to you guys, I will add some additional slides to this lecture so that you can read those on your own and you can just recapitulate all the things related to the MVC model. Okay. So one of the patterns that I want to talk about, which does not exactly fall under any of those categories that we saw in case of J2EE technologies, but it specifically falls under creational patterns, is the Singleton pattern. So the reason we are going to discuss about Singleton pattern is because it is extensively used in any kind of application development, and it provides one of the best ways of creating an object. So what kind of problems does the Singleton pattern aim to solve? So Singleton pattern is used in case we need to create a class, and we need to make sure that we always have a single instance of that class. Okay. Also, Singleton pattern provides us a very good way of getting access to that single instance without needing to instantiate another new object of that class. Okay. So again, the main purpose of the Singleton pattern is to make sure that we always have a single instance of a class, and its another purpose is to provide a way to always get access to that single instance of that class. Okay, so let's see a very simple implementation. So on the left hand side here, you can see that we have a class called single object, and the single object class is basically utilizing the Singleton pattern. So let's see how it is doing that. Here, at first, we have created a static variable called instance, and the static, not variable, this is basically a static instance of the single object class here, okay? And the reason we are creating it as a static object is because we want to make sure that there is only one instance of this class, and we always want to return this vary instance whenever some other class needs access to it. So this is called a lazy initialization, because you can see that what we are doing here is we are essentially initializing this static object as null, right? So the reason this is called lazy initialization is because whenever this class is going to be loaded into memory of your machine, it is not going to allocate memory for this object instantly. Instead, what it will do is it will allocate memory to this instance whenever it will be used for the first time. So we will see that how that happens. Next, we have a constructor. Now, what you need to notice about this constructor is that it is private. So whenever we actually define this constructor as private, we are basically preventing any other class from creating this, from creating any object of this class, because the constructor is private, right? Next, we need a method which can be utilized to get access to the instance, right? So that method is the getInstance method. You can name it whatever you want. So we have named that method as getInstance method. Now, what this method does, it is at first it checks whether the instance that we have is null or not. So if it is not null, or sorry, if it is null, then it will be essentially creating an instance, or it will initially, it will be basically allocate memory to the instance that we have created here, right? So this will only happen the first time this instance is accessed. Afterwards, what will happen is it will basically not get inside this method or get inside this if block, and instead it will simply be returning the instance that we have already initialized some other time before. All right. Now you can see that we have used some special keywords here, like for example, in case of creating that instance, we have used the volatile keyword, and in case of the if block, we have used the synchronized keyword. Now the reason we are doing this is because we want to make this implementation a thread-safe implementation. What that means is, suppose multiple threads are accessing this class at the same time, right? Now suppose that all those threads are accessing this class for the first time, that is when this instance has not been initialized yet. Now if multiple threads access this method, that is this getInstance method at the same time, there is the possibility that this instance variable will be initialized multiple times, right? So we want to avoid that. And for that, what we are doing is we are basically using the synchronized keyword to make sure that only one thread can access this method at one time, and basically make sure that the instance object here is going to be initialized only once. Okay. As for the volatile keyword is used to make sure that there is that this instance object is not stored in any cache memory. So whenever any other class tries to access this instance object, they will always get access from the main memory. Okay, so any change that you do to this instance variable or this instance object is going to be stored directly into the main memory without actually storing any copy of it in the cache memory. So again, this ensures that all the other classes, whenever they actually access this instance object, will get the same copy or the same version of this instance object. Okay. All right, so let's talk about the front controller pattern for now. So what kind of problem does this pattern aim to solve? Well, let's think of a scenario. So in any case, or in any kind of web application, we know that we will have multiple views or multiple screens. Now, all these views will have to support different kinds of services, like different kinds of system services, content retrieval, view management, security, navigation, and so on. Now, in case there is no centralized mechanism to actually manage all these views, we can have two kinds of problems. Each view is going to require to provide its own implementation of the system services that we just mentioned here, which often results in a duplication of code, right? So basically, to implement all these services for all the views individually, we will basically have to write down the same code over and over again for all the views. Also, the view navigation is left to the views themselves. So this is we can already understand that this is a bad idea, because this results in a amalgamation of view content and view navigation, right? So how can we solve this? Or how does front controller pattern aim to solve this? Well, the solution is pretty simple. The front controller pattern says that we should use a controller as the initial point of contact for handling a request. So whenever a request is actually received, the controller is going to manage and handle different kinds of services like invoking security services like authentication and authorization, delegating the business processing, managing and choice of an appropriate view, handling errors, and so on. And then finally, delegating the control of that request to the appropriate class or the appropriate servlet. Okay, so very simple strategy. So here you can see a diagram that actually shows, or that actually showcases how the front controller pattern works. So the client is at first going to send a request to the controller. The controller is going to delegate that request to the dispatcher, and the dispatcher is going to forward that request to the appropriate view. The client can also send a request to the controller, and the controller can directly send that request to the view in case it does not really require a dispatcher. Also, a client may also send a request to the controller, and the controller, in case it does not actually require any view, it can directly process that request by taking the help of different helper classes. So let's take a bit more detailed look at each of these objects here. So the controller is the initial point of contact for handling all requests in the system. So as I have mentioned, the controller may delegate to or may take the help of different other classes to perform system services like authentication, authorization, and so on. So basically, controller is the first point of contact for any kind of request. Next, we have the dispatcher. Now, in case the controller needs to delegate the request to any second view or any other view, so the controller is going to take the help of the dispatcher. Now, we already have studied how request dispatcher works. So this dispatcher object is basically implemented by using the request dispatcher object. Okay. Next, we have different helper classes. So different helper classes perform different kinds of functions. They don't exactly contain the core business logic of your application, but they contain some functionality which helps in making your application run smoothly. So different kind of utility classes are basically a category of helper classes. So the controller can take the help of these different helper classes to perform different kinds of functions which are necessary to make your application work properly, right? So these helper classes can also be accessed by the controller in case the request requires it. Finally, we have the view, and the view basically, or not finally the view, basically the fourth point here is the view. The view represents and displays information to the client, right? The view retrieves information from a model, and the helper classes support views by encapsulating and adapting the underlying data model for use in the display. So basically, whenever we want to actually show something to the users or to the clients, this can be done with the help of our helper classes or some other classes, which will basically help to generate the content of that view with the help of different models. So how do we exactly implement this, this front controller pattern? Well, it's pretty simple. We simply use the servlet front strategy, which basically says that we have to use, or we have to implement the controller as a servlet. So whenever the client sends any request to our server, there is going to be a servlet which is going to act as the controller, and this controller servlet is going to basically process the request of the client and take the help of this dispatcher and helper classes or objects to process that request and delegate that request to the appropriate resource. Okay. Now let's talk about data access object pattern, or the DAO pattern. And this pattern falls under that category of patterns that is under the data tier category of patterns, which are utilized whenever we are concerned with JEE technologies. So let's see what kind of problem this DAO pattern aims to solve. So we know that in case of any JEE application, or in case of any application in general, these applications need to utilize persistent data at some point, right? Now, when we say persistent data, we mean that some kind of mechanism to store our data in a way that that data is not going to disappear the moment we actually turn off our machine. So in very simple terms, that's what persistent data means. So anyway, different applications will need to use different kinds of persistent storage mechanisms. And the API and the functions that are used to access these mechanisms are drastically different from one another, right? So again, the access mechanisms, supported APIs, and features vary between different kinds of persistent stores, such as RDBMS, object-oriented databases, flat files, and so on. So basically what this means is that if we are using RDBMS as our persistent storage mechanism, then the API that is going to be used to access our RDBMS is going to be different from the API that is going to be used in case we are using an object-oriented database. Now, since there is such a disparity in the implementation of these different persistent storage mechanisms, what happens is, in case we do not have a common mediator between our actual business logic classes and our actual database, then what happens is our business logic classes need to include the implementation details of accessing these different kinds of databases, right? And that is actually a very bad design because it introduces tight coupling between our business logic and our database, and we do not want that. So how does DAO pattern aim to solve this? Well, DAO pattern tells us that we should use a DAO object or DAO interface to abstract and encapsulate all access to the data source. So what happens is the DAO pattern is going to provide a common interface to our business logic classes, and this interface is going to expose the different methods that our business logic classes are going to use to access our databases. Now, the actual implementation details, of this of accessing these databases are going to be hidden by our DAO pattern because the business logic classes do not need to concern themselves with the actual implementation details of accessing those databases, right? So this introduces a separation of concerns strategy here, and the business logic classes do not have to worry about changing their implementation because they're only going to be dealing with an interface, right? So the implementation details can change whenever it comes to accessing those databases, but the interface does not really change, right? So we don't have to worry about changing our business logic code whenever we decide to maybe change our database in the future, right? So that's what the DAO pattern aims to solve, or solves by proposing this kind of solution. Now let's take a look at this diagram here. You can see that we have four objects here: business object, DAO, data source, and transfer object. So let's try and understand what these things mean first, and then we will take a look at what is happening here. So the business object represents the data client. So suppose our client or our user needs to access some data from our database. So basically the business object is going to be delegating that instruction from the client to our DAO, right? So a business object may be implemented as a session bean, or basically an EJB, or any other Java object or servlet with the help of some helper classes as well to access this data source. Next, we have the data access object, or DAO. So data access object is the main player in this whole scheme. The data access object abstracts the underlying data access implementation, as we have mentioned earlier, for the business object to enable transparent access to the data source. So the business object, in case it needs access to any information from the database, is going to communicate with the DAO, and the DAO is going to give that information to the business object. So let's see how the DAO plans on actually giving that information to the business object. So we have the data source next. The data source is basically the actual database that we have in our backend. So this data source can be implemented as an RDBMS, as an object-oriented DBMS, an XML repository, as a flat file system, and so on. It doesn't really matter in this case. What the DAO will do is it will basically have the necessary implementation details for accessing this data source, but our actual business object is not going to be aware of this implementation details, okay? And finally, we have the data transfer object, or DTO. So DTO is something you will see used in conjunction with DAO, because DTO basically acts as a data carrier. Now consider this scenario. Suppose you have an employee database or employee table in your actual data source, okay? And as a client, you want to access the employee records of an employee with ID 1. Now, this table that we are talking about has attributes like suppose ID, name, and phone number. Okay. Now, when the client actually wants this information, we need some kind of way to represent the data that we are going to return to the client, right? So in case of our data source, suppose if we are using Oracle, this information is going to be stored as a table, and the information that we're looking for is located as a row inside that table, right? Now we can't really return the whole row to or return the row to the client directly, right? We need some way to, or we need some kind of way to represent that row that is going to be understandable by our business object and to our client. So the DTO, or data transfer object, acts as the carrier of that information. Okay, so the way you can think of it is this. We can have a simple employee class that will have 3 attributes like ID, name, and phone number, and an instance of that class, that is an object of that employee class, is going to represent the actual row of the table, of the employee table that we are looking for, right? So that's the whole purpose of transfer object. So you can basically think of data transfer object, or DTO, as a simple POJO, or plain old Java object that contains the information that we are trying to access. Anyway, so now let's see what is happening in this diagram. So suppose you want to, or your client wants to read some information that is present in the data source. So the client is going to ask or is going to invoke some method inside your business class. That is, it's going to invoke some kind of business logic in your application. So the business object is going to communicate with the DAO. So what it will do is, at first it will create a DAO object. Now it will use that DAO object to get the data that the client is asking for. So when the business object asks the DAO to give that data, what the DAO will do is it will essentially create a DTO and use that DTO to store the information that is present in this table, right? And the information is the one that the client is looking for. So after the DTO has been created and the DTO contains the information that the client is looking for, the DAO is going to return that object to the business object, and the business object is basically going to show that information to the client or do whatever other processing that needs to be done. Now this is for in case you need to read some data from the database. Now what if you want to write some data as a client? So in that case, what happens is your client will at first tell the business object that it wants to store this certain information. And what the business object will do is it will basically create a DTO, or data transfer object, that basically carries that information. And after the DTO has been created with that information, it will again utilize the DAO class to store that information in your data source. Okay, so from this you can already understand that the main gist of this whole pattern is that the DAO class, or the DAO object, is going to be responsible for any kind of business logic related to the data source. Okay, by business logic here I mean the logical code, or the logical functionality that you will need to read, write, or do anything with your data source here. Okay, so that's all the DAO pattern does. Now, in case you're wondering how you're supposed to implement this pattern, it's pretty simple. You're going to have an interface. You can name it whatever you want, but the common convention is something like sample DAO interface.java. So that's what you can name your interface. So yeah, that interface is going to contain the methods that you want to expose to your clients or to your business objects. That is, these methods are the ones that the business object can invoke in case it wants to do any kind of operation on the database. Okay, and there is going to be a second class which is going to implement this DAO interface, and this implementation class is basically going to contain the actual implementation details. Like suppose if you're using an Oracle database, it will contain things like establishing connection to that database, performing necessary queries, and so on. Okay, so that's it for today's lecture. Here you can see some of the reference links that I have used to design this lecture. Please visit these links in case you want to read more in-depth information about them. Also, this last link here contains an example of the implementation of the DAO pattern. Okay, so I encourage you to visit this link in case you want to see an example of the DAO pattern in practice. So anyway, if you guys have any question, let me know. I will see you guys in the next lecture. So take care and stay safe.